Okay. Welcome to week 10 of NPTEL session of C programming. In today, we will be learning more about different kinds of sorting algorithms, arrays, and especially we'll be covering pointers and pointer arithmetic with respect to arrays. And let's see how this session goes. I will be discussing, as usual, first I'll start with the MCQs from previous year, and then we will be also covering a few programming assignments as well. So let me start with the MCQs and then we will go on to discuss the programming assignments. Okay, so as I was saying that today mainly the things that we will be covering are these topics like sorting of arrays, and also in that context we will be seeing swapping and use of pointer arithmetic. So without any further ado, let's get started. And also I want to add that if you are at any point of time having any doubt, then please feel free to unmute yourself and ask, and please feel free to interrupt me as well whenever you feel that there is something that you don't understand and you want to ask. Yeah, and you can also post it in the chat as well. Then I'll respond accordingly, because I'll keep on checking the chat every now and then. Okay, so let me start by sharing my screen. I hope my screen is visible to everyone. And just to confirm, can everyone see my screen? Okay, great. Okay, then let's get started. So this is the set of MCQs for this week. So let's start with question number 1. Bisection method is used to find. Okay, so yeah, one thing I also forgot, that we will also be covering the bisection method for finding the root of different transcendental functions. So this is what the bisection method does. So what it is used is it is used to find the root of a function for which the analytic forms don't exist. For example, say you want to find out sine x minus x equals to 0, or when is x equals to sine x. And generally speaking, these cannot be solved directly and analytically speaking. And then what you need to do is you have to solve it numerically. And one of the ways of solving such numerical transcendental equations is using this bisection method. There are other methods like Newton-Raphson and things like this, but for the sake of today's discussion, we will be only covering the bisection method. Okay, so that's what this is about. So let me just briefly tell you the idea about bisection method. Let me just open up Paint, where I'll just will be drawing in a hand wavy manner how a function looks like. So the idea here is that you have a function f, which is a function of x and equals to 0. So for what now by root of a function, you mean what value of x is needed for this function to be 0, right? So that is what is meant by root. For example, an example would be x equals to sine of x, right? So this is an example of such a function. Therefore, you can take these on the other sides, and what this would mean is that sine x minus x equals to 0, right? And now you want to find out x. So your fx is sine x minus x. Or you can go the other way around. It can also be x minus sine x. Either way, but the idea is that given an fx, you want to find out what value of x satisfies this, and that is called the root. And so what happens is that, say this is your x-axis, sorry, y-axis, and this is your x-axis, and you have some function like this, right? This is your f, and this is your origin, 0. So what this means is that this function does not have a root, because there are, as you can see, no values of x for which fx is 0. So this is a case where root does not exist. But if a root exists at any point of time, for example, let's change the color. For example, this function, which I'm now showing in red, will goes like this, and therefore there is a value of x for which the root exists, and this is precisely the place where this function cuts the x-axis. And as you can see, whenever such a thing happens that a function cuts through the x-axis, there is always a part of the function which is a kind of negative, and then there is a part of the function which is positive. As you can see, this part of the function to the left of this point is positive, while this part of the function to the right is negative. A function can also be like this, for example, some other function, and for this, to the left is negative while to the right is positive. But either way, as you can see, the point where this is satisfied, that when fx equals to 0, if you go to either side of it, either to the left of it or to the right of it, the sign of the function changes. It's either goes from positive to negative or negative to positive. And in such a case, a root exists. So what bisection method does is you say that the root lies somewhere between two points on either side. So say, for example, let me change the color once again. For example, if you have a root where you want to find out the root of this function, where this line basically, where this curve which is showing the function cuts the x-axis, you'll have two points to start with, which you call a and b. And what this would mean is that, say this is b and this is a, then what is meant is that the point where the kind of what this root lies is somewhere between B and A. So the idea of bisection method is that you say that you approximate or you guess that this is at the midpoint. So when you guess that, you say this is C, which is at the midpoint, and say this is your midpoint. Although in the drawing it doesn't seem so, but just for the sake of it, assume that this is the midpoint. And when you have done that, you see that you again evaluate the value of the function at this point. So at this point, the value of the function is this, at the point of C, which is the midpoint between B and A. And then you say, see that is the value of the function positive or negative. Now you know, for example, the value of the function at A is positive. And if you know that the value of the function at A is positive, say, let me take the example of this function, which is shown in, which I'm showing in green. Okay. So now you see that the value of this function to the like value of C is positive in here, while the value of B is also positive, while the value at A is negative. Then you would know that the root lies to the right of C, right? So then what you do is you get rid of this B and you assign this C as the new B, right? And then again you find the midpoint. So this midpoint would then again lie somewhere around here, right? Now when the midpoint lies somewhere about here, which is now your new C, and this is your new B now, now what you do is you ask what is the value of the function in here. And now you see that the value of the function at C is negative. And while the value at B is positive, while the value at A is negative. So what this would mean is that now kind of your C has moved to the right of the point which you actually want, and therefore now what you have to do is you get rid of your A and you assign your C to be your new A, because now the sign of C matches A. So whenever whatever the sign of C matches with either A or B, you reassign that to C. So now you assign this as your new A, and then you repeat the procedure, and what will happen is that these two bounds A and B will come closer to each other, and so close that it will be a good approximation to the point where this intersection is happening. And this is actually what you want. And then depending upon up to how many decimal places do you want it, you have found out the root of your function. So this is basically the bisection method in brief how it works. So the reason I spent so much time explaining this is because not only in the MCQs, but later on in one of the programming assignments, I'll also be covering in detail to code this algorithm up. So that's why I thought that this is a good time that I also explain how this bisection method is working. So obviously now to answer this first question, the bisection method is used for finding the right option is C, which is the root of a function. So let me know if there are any doubt. I am happy to answer it at this point of time, because later on I'll be also using this same concept of bisection to write the code. So if there are no further questions at this point, I would move on to the next MCQ, where the question is in dash, in the blank, the search starts at the beginning of the list and checks every element in the list. So what does this search mean? So this is actually linear search. We covered this briefly also in previous week. In linear search, what you do is you start with the beginning of the list, and then you check every element, and then whenever you find the match, you say, okay, I have found the match, and so this is the number which matches my list. So this is a linear search. And this is also one of the questions which is repeated from previous week, that what is the worst case complexity of linear search. So this is of log of the order of n. And the reason for that is that, say you have an array of numbers, and you check and you want to find out one particular number, where does this lie in your array. And the way you do this is you keep on checking every number in your list and until you find the match. And say if your number is at the which you are searching for actually is at the last of your array, then you have to do this searching operation or comparison operation for every element until you hit the last element. And so the worst case scenario is doing n operation, so it's of the order of n, right? So that's the right answer in here. Okay, so now the question is, what's the worst case complexity of the bubble sort? So for this, to answer this question, I have to tell you more about the bubble sort algorithm. Again, this is one of the sorting algorithms which we will be also covering later on in one of the programming assignments. So I think that now this is a good time to also explain you how this bubble sort works. And perhaps many of you have also gone through the lecture videos of this week and have already known about it, but just for the sake of giving you a kind of recap on what was discussed, I will again cover the bubble sort in this tutorial session today. Okay, so this is the kind of the bubble sort algorithm. The idea here is that you compare every adjacent element, and say you want to arrange an array in ascending order, then you keep on comparing every adjacent element unless you, for the first iteration, you hit the end of the array. Then for the next iteration, you hit till the second most element of the array, and you keep on doing this until the second element of the array, because in the first element of the array then gets automatically assigned. So this is how the bubble sort algorithm in general works, and I am now going to go through this specific example just to show you this algorithm in action, and then we will be later on coding this up as well. So here is an array to start with. You see it's this 6035. So these are the 4 elements of the array, and you can see that as I was saying, you start with from the left and then compare the adjacent elements, and here you are arranging in ascending order. So that would mean is that the larger elements will go to the right and the smaller elements will come to the left of your array, right? So the way this would work is that you first look at the first 2 elements, and then you say that, okay, I see that they are misplaced because the larger element is to the left and the smaller element is to the right, but you want the other way around, that the smaller element has to be to the left and the larger element has to be to the right, because you are arranging the array in ascending order. And because of that, you do a swapping, and therefore your 0 and 6 positions are getting interchanged. So in the next position, you see 6035 has changed to 0635. And then again, you make another comparison, and then again, the same holds true, that here you have a larger element to the left, and therefore you do another swapping, and then the new is 0365. And then you again do another swapping, and then you will have something like 0356. So, and now that you are at n minus, so you see that you first compared the first 2, like element 0 and element 1, and then you compared element 1 and element 2, and then you compared kind of element 3 and element 4, right? 0, 1, 2, 3. Sorry, element 2 and element 3, right? Because this is like, as you already know in C, that everything starts from 0. So this is element 3. So once you have done this and you have made the complete iteration and you have gone till n minus 1, you have already had the last element which has been sorted and put in its position. So the largest element automatically goes to the right. And then the array which is unsorted now is actually of the size of n minus 1. So now these are the three elements which are unsorted, and then again you do the next sorting algorithm where again you do something like you start from the left and then again you compare 0 and 3, and now these are at right places, no need for swapping. Then you do another comparison of 3 and 5. Then this also doesn't require any swapping, and then you say that, okay, I have gone till the second last element, and then this is obviously at its right position. And then again I go back and I check that now there are only two elements which are left to be sorted. So I check these two elements and I say, okay, these are already sorted because they are at the right positions. The smallest is to the left and the largest is to the right. And therefore, you have gone to all the elements, and the first element automatically gets sorted because of the because all the elements are at the right positions of the first element. All the elements except the first element you say is at its right position, then the first element is obviously at its right position. So you do not need to check again. And therefore, the number of passes, as you can see, your array was of size 4, and the number of steps that was needed for going through every element was 1, 2, 3. So you needed n minus 1 steps for this, as you can see in here. And the number of sorting operations that you would have needed is at every time you do an n minus 1 steps, and at every time you do n such like operations. So you have n times n minus 1 by 2, and the half is because you are kind of having two elements to do it at every point of time, right? So the number of comparisons is n times n minus 1 by 2. And the number of passes that you need for this bubble sort is n minus 1. Okay, so now let's go back to this question, and then it says that what is the worst case complexity of bubble sort. So as I was saying, it's n times n minus 1, which is for a very large number of size of or value of n, for which will mean a very large array. It will be of the order of n square, because 1 is very small compared to a very large value of n. So what this would mean is that, say, imagine you have an array of length 1000, then 1000 times 1 minus 1 is 999, which is also very close to 1000. And so n times n minus 1 is roughly of the order of n square. So the worst case complexity of bubble sort is n square. So at this point, if you have any questions, please feel free to ask me. Okay. So the difference between best case and worst case means is that, say you have already started with an array which was already sorted, right? Then you would not actually need to do any of the operations, right? Because you have your array is already sorted, and therefore you do not have to repeat all these operations. So that's called the best case scenario, because something is already sorted, so you do not need to do any other operations. So the bubble sort algorithm can do not have to go till the end of it. Similarly, in this example specifically as well, which I was showing, let me go back to it. As you can see that after the first two iterations, things already got sorted, right? So although for the sake of completeness, we were then again repeating the same procedure here as well, where we were trying, like after the first step, we were again trying to compare and do the sorting and things like these. But as you can see that since things are already sorted, you do not need to carry out all these steps. So that's called an intermediate case scenario, where there were some sorting operations which were needed, and after a while you do not need any sorting operations because things were already sorted. Now, depending upon what kind of array you had, like if you had some other elements in here, then obviously you would need a sorting to be done. And in that case, that is called the worst case scenario. And this would generally happen when, say, your array is arranged in a descending order and you want to arrange it in an ascending order. Then you have to carry out all the operations till you reach the end of the array. And at no point in the midway that you will have an array which is already sorted. So that's called the worst case scenario. While the best case scenario is you already have an array which is in ascending order, so you do not have to carry out any operations. So that's the best case scenario. And the worst case scenario is you have to carry out all the operations till the end to get the array sorted. So in that specific case, you see you have to carry out n times n minus 1 comparisons in order to get this array which is sorted. So that's called the worst case scenario. in a bubble sort. So is that clear? No, the best case scenario is 0. You do not need to do anything because your array is already sorted. So the best case is 0, right? You do not need to do any operation and your array is already sorted. But the worst case scenario will be n square because you have to do all the operations. And in general, like if you have an array of any arbitrary values, you often do not need to go till n square. So you will, in principle, when you are doing it for any general array, you have to do something in between no operations and n square operations. So somewhere in between, that's kind of an intermediate case. Now that will depend on how many operations actually you need to do, will depend on the values that are given in your array. Okay, so what is the maximum number of comparisons that can be done in a bubble sort? So as you can, as I was showing you earlier, it's half of n times n minus 1, as you can see, and I'll also share actually the link to this article, which you can see for yourself. I think that this is a very good description. I'm sharing it on the chat. You can also have a look at this article where in detail the things about bubble sort is shown, and also its implementation in various different code is also shown, which you can obviously check it out, but we will also be writing our own bubble sort code after a while. Okay, so once this is done, let's go to question number 6, where what are the correct intermediate steps in the following data being sorted by bubble sort, right? So the data the thing you start with is 74182, right? So let's go and type the 74182. This is, I think, the array was, let's just confirm once again, 74182. So now let's find out what will happen when you do the bubble sort. Oh, this is what you start with. So you start with the leftmost. So you do this 47. So this obviously is needs to be swapped because the larger value is to the left. So you do a 47182. And whenever I'm swapping, I'm just giving a marker S so that I know that I'm doing a swap. And then after that, you again do another check, but now you do start from here because this is already done, like you have already compared the first two, and then you compare the next two. So this is the one you compare again. So then again, you see this needs a swapping because the larger value is to the left. So you do a 41782, and that again is another sorting. And then you do this, you start from this, and therefore here you see that things are already sorted, and therefore this will remain the same 41782 because things are already sorted. And then again you do the last two where it requires another sorting because again 8 is to the left of 2, which you do not want. So you again want a 41728, and this is again another place where you have done a swapping. But with this S, I just mean I'm doing a swapping. Okay. So now we know that I have gone. So this is 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is an array of element length 5 and 1, 2, 3, 4, 5. So I have done the operation till 5, and I know that the largest array, the largest element is now at its right position. So this is the sorted part, while this is the unsorted part, which again requires sorting. So we will again start from the first element, and we'll see that, okay, we see that 4 is to the left, which is not right. So we need a swapping for 14728, and this we had made a swap. And then again, we'll then the next two. So again, next two is now it is at its right position, so it doesn't require any swapping. So 14728, and this didn't require any swapping. And then this two again requires a swapping because now 2 needs to be to the left. So 14278, and I'll just again put an S in here. And as you can see, now the last two elements are sorted. So now these two are the sorted part of the array, while these three still require some sorting steps to be done, right? So now we'll again compare the first two, which is at its right position. So there is no step, that's no swapping that's needed. So we'll just put it in here, and then we will compare the next two, where we see obviously a sorting is required because 4 is to the left. So 1, 2, 4, 7, 8. And obviously we have done the swapping, and once we have done it, we have reached the end of it, because these are the three which were the unsorted part on which we were carrying out the bubble sort. So we have reached the end of it, and now we see that okay, these three are now sorted and it's at the right position. The first two are not, or they are perhaps, because if I go the next step and now compare the first two, I'll see that there are no sorting that is needed for these two because they are at the right position, and 1, 4, 7, 8, and that's the end of it then. So then let's out of these filter out the positions where we have done the swapping. So we have started with 7, oops, sorry, 74182. So 74182 is the array we have started with after the first swap, which is 47182. After the next swap, it's 41782, and followed by okay, it's this one, 41728, then 14728, 8. So this is 14728, then 12478, and this is it. So you see these are the steps where the swapping has happened, and so this is what were the steps that were involved in this bubble sort algorithm. So let's check with the question. So the first thing is 47182. So this is the first one. You see 47182. So let's see, out of this, all these are matching 47182. So then all this qualifies. Then let's go to the next one where we have 41782. So now let's see 41782. So 41782 are the first two matches here, because now I have a, you see that we have a 41782. Then out of something out of this first two will be the right option. Then let's look at the next step. It is 41728 is the next one. So 41728 is the next one. So I think this is also the same in the here. The next one is also 14728. So 14728 is the next one. So let's go and see. 14728 is the next one. 14728 is the next one, and then we do after 14728. I have a 12478, right? And so I have a 14278. So this is the next one, because you see 14728. Let's go to this one, 14278. After that, 14278 was the swapping that was done, which was this 2 and 7. And after this, we move on to this one, and then we did a one. Okay, So let's see. I think I perhaps have done something which is not right in here. So let's just look at it. I have a 14278 in here. After this, I came in here and I did the first check, which was okay. And then I did the next check, 12478. Okay, that seems right because I am now swapping these two. Go to get a 24 here, 78, and yeah. So let's see, 41782. So let's do this in here so that I can compare the bubble sort thing. Let's see what are the options then. Okay, so let's see. So this is the first one, 74182, and then 47182 is the next one, which is matching for all of them. And then I go to 41782. So I have a 41782. So obviously, then this one, because this one is 41728, whereas this is 41782. So out of these two, then you see 41782 is the right one, because after 47182 it should be 47182. It must be 41782. So 47182, it's 41782, where the first option is 41728, while the next option is 41782. So you see the next option matches. So the option B is the right answer in here, because this is the one where the things are matching. Okay, so I hope this is now clear that option B, why option B is the right answer, because first we eliminated, looking at the next step, we eliminated where we were able to eliminate the option A from option B, and looking at the very second step, we were also were able to eliminate the option C and option D. At this point, if there are any questions, then please ask. And this will again be clear when I will be also going through bubble sort and coding this up, and then we will be showing you that we'll just use these values and show you what are the steps that is coming in. Okay, so I hope this is clear. So let's go to the let's see the bisection method. So the question is, what's the disadvantage of bisection method? And the disadvantage is that it cannot find out computationally, it cannot find out complex roots. What this means is that, say if you have something where you have multiple crossings, then it is difficult. So what do I mean by this is that, let me get rid of all of these. And here the idea is that, again, you have your x and y axis, and imagine that your function, you have some function which is something like this. Let's not be too fancy. So something like this. Then what this would mean is that you are now having multiple roots in here, because at multiple points the function crosses 0. And now if you have a bisection method where your A is like this and your say B is somewhere like this. So let me use a different color for this. Say your A is like this and your B is somewhere like this. And then the point is, it becomes quite difficult for the bisection method to converge to either one of the roots. And therefore, it's quite complex if you have a function which is quite has this multiple roots or other complex natures like this. It becomes difficult for the bisection method to find the root. Okay, so now this next question is about pointers, and especially in the context of using pointers in arrays, and there is a pointer arithmetic that is also going on. So the thing that is happening in here is that you first you see in the first line an array is getting created. So is there any questions at this point? Okay, I think there are no questions, so let's move on. So you see that this is the array, and you have 10, 20, 30, 40, 50. So you have this 5 elements in this array. And when you do the first thing, this is in star ptr1 arr, what this would mean is that your first pointer points to the memory address of the first element of the array. So the first PTR1 is an address or a pointer to the first element in the array, and similarly PTR2 is contains the address of the element of the array, which is PTR1 plus 3. So now, since PTR1 is an integer pointer, and therefore when you do a plus 3, it will move by 3 integer sizes in your kind of the array in memory. So then what this would mean is that PTR1 plus 3 is actually referring to the element at index 3 in the array. So it's 0, 1, 2, 3, right? So this is 40. So PTR2 actually, the value of PTR2 is not 40. The value of PTR2 is the memory address which where 40 is there. And similarly, the value of PTR1 is the memory address where 10 is there, right? So now when you do a star PTR minus star PTR2, this star means dereferencing a pointer. So you say what's the value at this address. So the value at this, the address of PTR2 is 40, while the value at the address of PTR1 is 10, and therefore 40 minus 10 is going to give you 30, and therefore the answer to this question is 30. And that's what you see in here. Okay, so now the next question is, what is the solution to the equation using bisection method up to 4 decimal places? Consider root lying in the positive quadrant only and compute the root till 5 iterations. Okay, so the idea here is that we want to find out the root of this function, which is x e to the power 2x minus 3x square minus 5. So for this, I will also open up something called Desmos, which is a popular tool for plotting it, so that you also get an idea of how this function looks like. And therefore, of course, we will also be kind of solving this function in and finding out the root. So let me open up Desmos, where I'm just going to plot this function, and let me open up the graphing calculator, where I'm just going to graph it. So let's see what's the function. It's x times exponential of 2x. So we have x times exp of 2x, and then you have a minus 5. Let's see. You have a minus 3x square minus 5. So you have a minus 3x square minus 5. So you see, this is the function. As you can see, it passes through the x-axis at some value. If you look at it here, the value is around 1.036 is where it passes through the x-axis. So this is kind of the root of the function, and this is exactly what we will be trying to find out using bisection method. That's what's the root of this function. So that would mean that what value of x for which this function is 0. And this is at around 1.036. So we'll see how this turns out when we try to find this using bisection method. And for coding, just like always, I'll be using VS Code. So let me open that up. So I have already a hello world code written in here, which I am going to change for this particular problem. Okay, so let's first define the function. So this is kind of the function, and the other thing library which we would need is the math library, because we are using something like exponential and things like this. So we'll need the math library, and here we are going to change the function. So it's like x times exp of x. So let's go in here, x times exp of 2x actually. So x times exp of 2x, x times exp of 2 star x minus 3x square minus 5. Minus 5. This is exactly what we want to return. And here now we will be trying to find out the value of the function. So now I'll just have two numbers, which is to the left and to the right. So I'll just call it left as 1.0 and right as 1.5. So between 1.0 and 1.5, sorry, I put one more dot in here. So now this is done. So I'll then have a mid, which is like left plus right by 2. This is kind of the mid value. And after I have done this, I have an epsilon, which is 10 to the minus 6. So I want it to go till 4 decimal places. So I just get like this. And then I'll have an int itar equals to 0 because I'll do an iteration here, right? So I think the iter will be 1 because the first iteration is just doing this. And then what I'm going to do in here is that I am going to find out the left, right minus left is greater than EPS. So this is my epsilon. And here inside this, what I'm trying to find out is I'm going to do something like a function mid and function left. So what this would mean is that the value of the function at the midpoint, which I was in the, while I was drawing in paint, I was writing it as C. So that's the value at the midpoint. And now the value at the left, if they are less than 0, means the value at the midpoint and the value of the left are not equal. Then that would mean is that the right value is going to get the value of the midpoint. Otherwise, what is going to happen is the left value is going to get the value of the midpoint, right? So this was actually already something which I discussed a bit ago. So let's recap on that. Say you have something like this. So this is your left. This is kind of your let me change the color. So this is kind of your left, and this is your right. Okay. So now we are trying to find out the midpoint, which is in here, and therefore now you see that the value of here, if you multiply the value here with the value here, what you will get is some value which is less than 0, because this is negative and this is positive. So multiplication of two quantities of the same sign is going to give you something which is positive, while multiplication of two quantities of different sign is going to give you something which is negative. Because if you multiply two negative numbers or two positive numbers, you will get a number which is positive. While if you multiply two numbers, either of which is negative and the other is positive, then obviously you'll get a number which is negative. So now what I'm trying to do is I am trying to find out the value of the function in here, which is kind of the, sorry, but here, which is the midpoint. And I'm trying to look at what's the sign of the value at the midpoint with respect to the left value and with respect to the right value. So now if the sign matches the left value, then I will I will update the left value to this new value, right? Now, but if the sign matches the right value, because now you see that if the sign matches here, kind of matches the left value, then what would mean is that I am still to the left of it. But if the sign does not match the left value, then I have already crossed the root, because you see that the root, let me highlight it by red, the root kind of lies in here. So now if the sign, and this is about the sign where the this is the point about which the sign of the function changes. So now if I find out the mid value and I see that the sign is same as the left, then I change the mid value to the left value to the mid value now. Or if I see that the sign matches that to the right, then I change the right value to the to this value, right? So for changing the sign match, we just multiply the value of the function in here with the value of the function in here. And we then check whether it's greater than 0. If it is greater than 0, then the sign matches. Otherwise, the sign doesn't. This is exactly what we do. You see, it's less than 0. So then if it is so less than 0, then what would mean is that the sign of the function at the mid value and the sign of the function at the left value does not match, then what would mean is that the mid value has to be assigned to the function to the value at the right. So the right value gets re-updated to the mid value. Else would mean that they match, and therefore if they match, then the left value has to be reassigned to mid value. So that's what is done in here. And then we again recalculate the mid value and and then increase the iteration, right? And after the end of it, so let me print it. Like, what's the value we start with? Okay, so let me do that. At this iteration, the value of the function is this. And let me also do that before even I begin the function. So I'll have the first iteration, the value of this, it is this, and then the next iteration, the value of the function is the other thing. And since I want something which is of the order of 4 decimal places, therefore what I'm going to do is that I will only print stuffs which are of the 4 decimal place. And at the end of it, I will again do a printf, and I'll just show the root, which is the mid value which I am getting. Okay, so once this is done, let me run the code. Right, so you see I have started with some value, and I am going from one iteration to the other iteration, and you see that the value of the function that I'm starting with is changing, and now it is going closer and closer to the value which is what is needed, or what is the root, which we have already seen from the graphing calculator. If you remember, the root was around, let's see, if you look at it, the root was around 1.036, and I come here, you see I am kind of converging towards this 1.036 value. So it's 0.356, right? So here, now the question was to look at what is the value of the function after a first few iterations. And this obviously depends on what you choose as your A and B. But let's see if we have something which is close. So 1.0312 is kind of the value which the code is looking for. And indeed, you can see is 1.03 is close to what you are getting. So now the idea here is that this is going to change here and there, because it really depends on what values you start with. But you see that after this iterations of 4, you see the value is 1.0312. But then again, things change. But this indeed matches the value of 1.0312. Okay, so now let's move on to the final MCQ, and you can see the options are not properly given in here, but let's just go through the code. And I do not know what is exactly asked in this question, because that's not what is given in the options. It just asks you to find the output of it, and this is based on simple pointer arithmetic. So let me just briefly walk you through what's happening, and without discussing what's the right option, because as you can see, that's not given in here. The different options with this question. So it's just the question is given, so let's just solve it as it is. Okay, so you see an array is getting created, and the elements are 10, 12, 6, 7, and 2. And then you create an integer I and an integer pointer P. Oh, by the way, before I go on to discuss this, is there any doubt which you might be having? Then please feel free to ask. Otherwise, I'll just move on in a few minutes. Okay, I see there are no questions, so let's move on. So here you can see there is, as I was saying, an integer and an integer pointer. Two are getting created, and then p equals to a plus 4. So what this would mean is that when you write a, it's just the name of the array. Then this is nothing but a pointer to the first element of the array, and then you give a plus 4. What this does is it updates you and gets you to the element with index 4. So its element with index 0 will be just a, and then plus 4 is element with index 4. So 0, 1, 2, 3, 4. So it takes you to the very last element of the array. And now what you are doing is you are running a for loop. This for loop goes from starts from 0 and goes till 4. So 0, 1, 2, 3, 4. And now you are just showing the elements of the array. And here you see that p, now p is, as I was saying, is a pointer. So this in principle is also an array, because arrays are defined as pointers by default. And you can see that minus, in the first iteration, it's minus 0, which is 0. So you as you know that the p is pointing to the last element, so the element that gets printed is 2, and then after that, when it becomes 1, then this p minus 1, then the element that gets printed is 7, and this goes on till you go and hit 4, which is p minus 4, which is 10. So what's happening in here is that the elements of A are getting printed in the reversed order. This is the idea of this code. So I hope this is clear. If not, please feel free to ask. So if there are no questions, then I'll just move on to the programming assignments, because now we are done with the MCQs, and now we will write a few codes which will include bubble sort and other sorting and different other algorithms. Okay, I don't see any questions, so let's then move on to the programming assignments. So let me load the programming assignment 1, and we will be going one at a time. So that this is again asking you to find the root of the of the following function using bisection method and using different kinds of error estimates. So you just change the error estimate and you try to find out the root. So it's 1, 2, 3, 4, and you show it till 4 decimal places, right? So let's do that. I mean, we have already created this function. So all we need to do is change the function for which we want to find the root. So let's write the new function in here, and let's see what our new function is. It's 2x cubed minus 3x minus 5. This is the new function, and let's try, and we don't need to show the iterations. So for the sake of it, let's keep it commented out. And let's now run this. Okay. Okay, now we also need to change this. So 2x squared minus 3x minus 5, 2x cubed minus 3x minus 5. So let's look at the question once again. Does it say anything about where do we want it? It doesn't. So we'll assume that the root is between 1.0 and 2. Right. Actually, we'll assume it's between 1.5 and 2. So we can also copy the same thing, and just like what we were doing previously, look at it in Desmos just to see how this function looks like. As you can see, this function again looks like this, and it has just one root, which is somewhere between like this is around 0.5. So you see that it's somewhere between 1.5 and 2. So let's have that as some kind of a reasonable estimate that this is 1.5 and 2, and obviously you see and Desmos is showing the root is around 1.719. So we are going to compare that. So let me go back. And you see I've given 1.5 and 2. So let's run this code once again. And I have 1.7188. So here you have a 1.7266. This depends on, again, what are the exact values of the roots that you choose for which this happens. So as you can see in this specific code, they choose 1 and 2. So let me also do that, because that's going to then give you values which are going to match. But irrespective of whatever you choose, as long as you choose two values which are at the two ends of your 0 and the root is between that, your bisection is going to work fine. So let me do that. And now let's change the APS, right? So now we are going to change the epsilon, which is again what it's been asked. So you have 10 to the power minus 2, minus 3, and 0.1. So let's first try the 10 to the power minus 2 one. So you have a 1.7227. So you have something which is 1.7227. So it's close to this, but yeah, obviously not exactly this. Again, this depends on what kind of detail you are doing it, but as long as you are having bisection, you will have something which is similar. And then again, 10 to the power minus 3. So you have 1.7192. So you see you have a 1.719. I mean, the last digit is not matching, but then again, it is fine, because again, as I was saying, depends on like the details of how you are coding it up, and then you have a 0.1. So let's try with the least accurate one, which is 0.1. So you have 1.7188. This is actually pretty good, even with such a small accuracy. So this kind of sums up the first assignment of this programming assignment of this week, and let's now go to the second assignment. But before that, if there are any questions, then please feel free to ask. Okay, I see there are no questions, so I can then move to the next one, where it's been asked whether to check a 3x3 matrix and see whether it's invertible or not. So finding the inverse of a matrix requires you to find the determinant of the matrix, and if the determinant, and then you need to divide the matrix with the determinant. And there are other steps as well, but one of the steps is dividing a matrix with the determinant value of the matrix. And so if you have a case where the determinant is 0, then you cannot do this division, and then the matrix is not invertible. And therefore, the question is to find out whether a matrix is invertible or not. You have to find out its determinant and check whether it's equal to 0 or not. If it is equals to 0, then it's obviously not an invertible matrix. So that's the idea, and it's specifically written 3x3 matrix, which makes it simple to find out the determinant, and that's exactly what we are going to now do right now. So let's create the matrix, and let me just get rid of all these. And let's, for simplicity, let's just have a matrix which is of just 3x3 elements, and have this thing right then just like this. Now, right, printf elements, enter the elements of a matrix. Obviously, this is what we want. and then we are just going to take in the elements. And now once we take in the elements, we are going to do something like float determinant. So with this, we are just going to find out the determinant of the matrix, right? So the way this is working is that this is using the determinant formula for finding out the determinant of a matrix. And as you can see, let me break it up for you to understand what's exactly going on. And then we are going to, it's going to be clear to you. So the way this is working is, let me write a sample 3 cross 3 matrix with its elements. So you have something like a 0, 0. Right. So this is kind of the matrix. You have you started with a 0, 0, and then 0, 1, 0, 2. So the first index is a row and the second index is a column. Then obviously you have 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So finding out the determinant means you take the first element, which is 0, 0, as you can see in here, and with which you multiply 1, 1 and 2, 2. So this is A11 and A22, and from that you take away A21 and A12. So A21 and A12 you take away, and this entire thing is what you multiply with the first element, so A00. And now for the second element, you have a minus sign because you have to subtract, and therefore you have this minus sign, and then you have the second element, which is A01, and to this thing you multiply again the 2 cross 2 elements, which are 1022. So you have 1022, and then you have 1220, because this is the element which is blocked. So you have 1220, so 1220, and the last one is 02. So you have a 02, and then you multiply with a 1021, 1021, and then take away 1120. So you have a 1120 to take away. So this is how the determinant is. And after all of this, what you do is that is equals to 0, you just print the matrix is singular. And so I mean non-invertible and singular means the same thing, is non else you print matrix is invertible, and you finish up the bracket. So this is kind of the rough idea. I have not followed the good indentation practices, so let me indent it. So yeah, so you see this is kind of the idea, and since you have only one element, I think it's better to just simply get rid of all these curly braces. Okay, now let's run this. So now let me put in the elements. So we'll try a few test cases. So first is 4, 5, 6, 7, 8, 9, and 1, 2, 3. So let me do this. 5, 6, 7, 8, 9, 1, 2, and 3. So the matrix is non-invertible. So that's what is expected in here, right? And then the next is it asks whether the matrix is invertible. We will try a test case where the matrix is invertible and see whether we get that as well or not. So let me go back and try the other case. So this case was non-invertible, and we surely find it's non-invertible. And then we try this 1, 2, 3, 0, 1, 4, 5, 6, 0. So let's see, 1, 2, 3, 0, 1, 4, 5, 6, 0. And the matrix is invertible. So yeah, you see that this is working pretty well. So as this is passing the test case, this ends the second problem of this week. And if there are again any questions, please feel free to ask or write it up in the chat. Okay, since there are no questions at this point, let me move on to the assignment 3, where you have been asked to kind of write an array, sort an array using pointers in ascending order. So we'll just take an array and sort it out, but now we will be using pointers for doing this. Okay. So there can be different sorts that we can use for this specific one. Let me just use selection sort, and because in the next assignment we will be using bubble sort for sorting arrays. So now let's use the selection sort here. So just to recap, how selection sort works is, say you have an array like this. So you start with the first element, and in the place of first element, you know that this has to be arranged in ascending order. So the minimum value has to be put in. So you go on and check what's the minimum value from your entire unsorted array, because now in the beginning everything is unsorted, and you see that the minimum is 11, and so you swap the elements at the position of the minimum value with the value at the first where the first element is. So now once you do that, you see 64 goes to the end and 11 goes to the beginning, and this part of the array is sorted. And then in the next, you again find out the minimum value, which is again 12 in here, and then you do the swapping, and therefore 25 and 12 get swapped. So two elements are getting sorted, and you keep on doing this up till n minus 1 elements, because if n minus 1 elements are getting sorted, then n elements are obviously going to get sorted. This is roughly the idea of how this is working. So let's go back then and do a selection sort using pointers. So let's open up VS Code. And now I just take an array. Say for just simplicity, I'm taking an array of 100 elements, but it can be anything. Now I'm giving a print, enter the number of elements in the array, and I take it as n, and now enter the elements. I take the elements of the array, right? Now, once I have done this, so let's see. I have taken all the elements. I just go in, and now I'm going to do a sorting. Now, as you know that all the sorts are come with a swapping of its own, so I'll do a swapping function. So for that, what I'll do is I'll have two pointers. So I'll take pointer A and pointer B, which are integer pointers, and now I'm assigning temp to like integer value, which is because star A would refer to the value at the pointer location of A, because it is dereferencing a pointer, so I'm keeping it in a temporary variable temp. And now what I'm doing is star A, which would mean the value at the pointer location of A, is assigned the star B, which is the value at the pointer location of B. So the value at the pointer location of B gets assigned to A, and then the value at B is then assigned to the value at temp, which was originally the value which was at the pointer location of A. So this is at the end of this, the pointers where A and B, which are being passed in here, their values get kind of swapped. And then this function is void. So this is going to just return nothing. Okay, so now let's try the selection sort, for which I am going to go till n. So now this would mean that, let's take this, I go till actually n minus 1, because as I was saying that if you go till n minus 1, then obviously your array is sorted and then you do not have to go to the last element, right? So this is the idea in here. And now we have to find out what's the smallest element from here. So we will have a for loop once again, okay, which is going to run from I. This is going to go till -1 j plus plus. And now the thing is, here I have to find out what first was the smallest element, right? So let's do that. So this will be first assigned the value at I. So smallest is the value of my array I. And now I go till j. And I also look at the position. I have the index, so I have the smallest index, which is also to start with has the value of I, right? And then what I do is here, I move in and I say that f. Now I start from I plus 1 because that's what I want to make the comparison with. So if, so now the idea is I want to use pointers. So for this, let me check in a pointer as well, star ptr. So now what I'm going to do in here is that I'll do ptr plus j is less than smallest. Then what I'll do is that the smallest value is then this and the index is this. So after this is done, I have found out the smallest index, and I also have found out the smallest value. So I guess here now what's required is a swap. So now what I'm doing is I am doing a swap ptr plus I. So this is like swapping the value at pointer I with the value of swap ptr plus smallest index. So the index of the smallest element is getting swapped. And at the end, I just do a print of the sorted array and I just print the array and then print a new line. Okay, so the idea here is using pointers. So this is how I'm only using pointers. See that I'm nowhere using any value of the array. So here also, instead of array I, what I'll do is I'll use a pointer. It's very simple. It's just ptr plus, sorry, ptr plus, and smallest is the value it there. So the value at ptr plus j is less than smallest. Then you do this, and the smallest index is j. So star is going to dereference your pointer. And now here, your smallest is ptr plus I. So this is ptr plus I, and you dereference it. And then here you do this. So ptr plus j, and you swap it. I think this is looks fine. So let's run the code, and later on, again, just like always, we'll be again later on trying to debug it if there are any errors. Let's go in here and see the input. So input is 8. So there are 8 elements, and you 90, 70, 30. So let's split the screen for it, which makes it easier. Oops, sorry. For me to type. Okay, so now I have something like 8 elements, and now enter the elements of the array. I must give a /n in here just to have it properly done, and then let me run this once again. So there are some errors which is happening. Let me close this. Let's see what's the error that's happening. I seem to be encountering some kind of a problem. Let me stop the code. Okay. So enter the element 8. So I apologize for the error. I don't understand what something was going wrong, but just some technical issues. But let's now try to do this. So you have 90, 70, 30, minus 10, minus 40, 20, 100, and 50. So let's do this once again, because like as I was saying, I want to give a /n and run this again. Let me run the code once again. Yep. So it's 8. And now let me go in here, which makes it easier for me to type. And let's now put in the values. So I have a 90, 70, 30. Oops. Something is. Let me close the VS Code and open it once again, because I think some technical difficulties are going on with it. Okay. So now I have VS Code ready. Let me run this. Okay, I think this is running fine. So let me give it 8. I have 90, 70, 30, minus 10, minus 40, 100, and 50. So you see the sorted array, which is minus 40, minus 10, then 20, 30, 50, 20, 30. Okay, I think what I did is I perhaps missed an element because of this being less than n. Because I think I missed the compare. So this is what I think I have missed. So let's run it once again, because I have to compare till the last element, but need not have to go till the last element. So I think this is perhaps what was missing in the previous one. Oops, I think I have given wrong values. So let's just run it again with proper values. Yeah. So let's see. So I have an 8 elements, and then 90, 70, minus 10, minus 40, 20, 100, and 50. Okay. So now you see, I go in here, I have minus 40, minus 10, then I have 20, 30, 50, 70, 90, and 100. Okay, so you see, I have now gone till the last element. So the reason as I was saying, is that I have to compare till the last element, but when I'm doing the pairwise comparison, I have to go till the last element to search for the smallest number. But in the larger array, where I am just determining the first element, like the first, like after every I iteration, till the ith element, everything gets sorted. So that doesn't need to run till the end of the array, but the comparisons has to run till the end. So that's this. Therefore, j needs to go till n, but it's okay to go till n minus 1. So this is what was going wrong in here. But now you see this is working. So let's also, for the sake of completeness, try the next test case as well. So here you have the 5 elements. So 20, 40, 50, 30, and 10. So you have, oh, I somehow missed the 0. Okay, let me run this once again. So you have a 20, 40, 50, 30, and 10. So you have 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. See, it's working great. So now this is done. So let's move on to the last question of this week, which is about bubble sort. As you can see, write a C program to sort a 1D array by using pointer and applying bubble sort technique. So this is what we are going to do. But before we move on to the final question, if you have any question from your end, please feel free to ask. We have a question about Newton-Raphson method in our assignment. Okay, so as I was saying that I have covered bubble sort, and Newton-Raphson is like another kind of method for finding out the root of an transcendental equation. And for different kinds of transcendental equation, either of the method works well. And the difference is that In Newton-Raphson, you just have one guess value, and you then try to iterate through it and to find out a better approximation to this. So I will just, since this is there in your assignment, what I'll try to do is after I discuss bubble sort, I'll try to just give you an example and try to motivate you the algorithm behind Newton-Raphson method, like how this is done. And then I would expect you then, because I have already discussed one of the root finding algorithms, you are pretty familiar. And once you know the algorithm of Newton-Raphson, I think you will be at a good point to code it up yourself. Okay, so let me go back to bubble sort, but I'll come to Newton-Raphson and just explain you briefly the algorithm of it. So here, so up till this, okay, let me just maximize the screen. So up till this remains, the code remains the same because we just take in the array, we take in the pointer. So till this, everything is the same. But now the idea is we are going to do a bubble sort. So we have to change this implementation where we were doing selection sort to a bubble sort, and we will be using pointers for it, right? So let's do that. But before doing this, I'll also have something like a new function is equals to 0. I'll let you know in the meantime what I mean by this, but let's just first write so for int I equals to 0. Now what I am going to do is I have a j which will run till so you see that here what I am doing is that I have int I which is equals to 0. So I and I less than n, I plus plus. So this goes from 0 to n minus 1. So this includes all the elements of the array, and here swap occurred is 0 because that's what I initialized this with. And then later on, what I do is that int j equals to 0. Now j, as you know, in bubble sort, after every ith iteration, the last element gets assigned to its proper position, and then the next sorting has to be done till on n minus I elements. So that's what's done in here. So you do like n minus I minus 1 and j plus plus. And now you compare this, that if so since we are arranging stuffs in ascending order, what we do is that we compare j and j plus 1. So what this means is that we compare the elements j and j plus 1. So at the position j, you have an element. At the position j plus 1, you have the other element. You just compare the two, and you see whether the element to the left, which is at j, is greater than element to the right, which is j plus 1. Then because you are doing in ascending order, the larger elements will go to the right and the smaller elements will go to the left. And therefore, this would require you to do a swapping. And therefore, we call the swap j and j plus 1, and put swap occurred equals to 1. So what happens in a bubble sort, as I was explaining, that bubble sort depends on how many operations that you need to do in a bubble sort would depend upon what are the values in your code. And you can always have an array where you do not have to go and make these operations and like this comparison till the end. And this is useful because if you have started doing bubble sort, and after a while you already have an array which is sorted, and then you do not have to do any comparison. And that would happen when in any one of the iterations you have gone from the beginning till the end and you did not require to swap anything. So that would mean is that all the arrays are already, like all the elements in the array are already sorted, and therefore you do not need to do any comparison and do any sort of kind of activity on how many times you are doing the sorting. So you have two elements and then next two, then next two, and you just do an n minus 1 comparison. So imagine that you have started with an array which is having n minus n elements. So in that case, you do an n minus 1 comparisons, and you had to do no swapping for this. Then this would mean that the array is already sorted, right? Because you didn't have to do any swapping. And when this happens in the very first go, then this is kind of the best case scenario where you have done an n-1 sorting, n-1 comparisons, and there you require no swapping to be done. So this is the best case scenario for a bubble sort. So the best case scenario is of the order of n. And as I was telling you earlier as well, while the worst case scenario is that you have to keep on doing this, and it will go till the order of n square. Okay, so this is done in here, and once this is done, let's just again try to run this code. So enter the elements of the array, and then again I will just have it in this place. So let's try this 7. So let's try the test case 70, 40, 80, 10, 200, 30, and 60. So the sorted array, you see 10, 30, 40, 60, 70, 80, and 200. So this is my sorted array. And you see this is working fine because as you see, things are getting sorted, and this is getting sorted in the bubble sort fashion. And with this, you can have a print statement inside this I. Like after all the j's have occurred, you just do a print statement for every I, a iteration, printing out all the elements of the array. And with that, you will be able to kind of also go through the question that was asked in the MCQs, and then in that you'll get the values in there. And then just like what I was doing previously, doing this manually, this thing which I was doing this manually for bubble sort, you can verify this by just printing it, having another print statement for at the end of every I iteration. And this will let you know how the arrays are getting manipulated while they are undergoing a bubble sort. Okay, so since this is done, I'll just wanted to discuss Newton-Raphson method, because as someone among you have asked about Newton-Raphson, so yes, I am going to then discuss that. So let me open up again Paint, where it's easy for me to just draw a representative function, and then we can discuss more on this. Okay. So let's draw two lines. This would correspond to your x-axis and y-axis. Okay, so as you know, as I was saying also, these are the two axes you see. I'm not a person who draws things pretty great, so pardon me for that. But imagine that these are like two lines which are perpendicular, and then let me draw a function in here. So say you have some function like this, say some sort of a function. Okay, let me draw something better, which is easier to explain. Yes, some function like this. And so the idea of Newton-Raphson method is that you start with some guess value. So the idea, so again, you want to find out the root, and the root for this function would correspond to the place where it crosses the x-axis, which I'm showing in black in here. So you want to find this out. So the what you do initially is you start with a guess value. So you'd say your guess value is this value. This x value is your guess value, which you call it x0. x0, and you have a function f. This is your function, and so at this point, what you do is that once you have found out x0, this is your guess value. So you start with x0, you find out f of x0, right? So the value, so this thing, the size of this is nothing but f of x0, because that's the value of the function that you have found out. And from here, you then try to find out the slope of this function. So the slope of this function is f prime. So if the function is something which you can differentiate, easily, for example, if your function, as I was saying, as an example, okay, let me change the, since I'm drawing the function in like this. So just for the sake of this example, this may not be right, but here you have some function, say sine x minus x, right? And for this, you find out the derivative of this function, right? So the derivative of this function, which is f prime of x, is cos x minus 1, right? And therefore, you also find out derivative. So not only do you find out f, you also find out f prime at x naught. So you find out f of x naught, and f prime of x naught is, as you know, by definition, derivative is nothing but the slope of this function. So you know f prime of x naught is the slope of the function at the value of x naught. So this is kind of the slope. And the idea is you find out where the slope intersects the axis, which is the x-axis of your function. So which is, say, if you look at this, let me use a yellow marker. This is the point where the slope intersects. So this becomes then your new guess value, which you call it x1, right? So let's try to find out what is the value of x1 is. So you know this value is x naught, right? And the slope is dy dx. So you have y, and this you don't know, and you dy dx is f of x naught. So what this would mean is that this value, which is x naught minus x1, is this value divided by, so in the numerator you will have f of x naught, right? Now this is nothing but the slope of the function, right? Because y by x is the slope. So you have something like f prime of x naught, right? So now if you try to find out what you need to do, then you make x1 as the subject of your formula, and if you rearrange this, what you will have is something like x1 is equals to x naught minus of f of x naught by f prime of x naught, right? So this is your new guess. So now you do the same thing. You found out x1. So the idea here is that, so let me do a different color of green. At x1, you again find out what's the value of that function at x1. You again trying to find out the slope of this function. So here the slope will correspond to something like this. Again, you trying to find out the slope of this function. The slope is here, would mean uh, f prime at x1, right? Once you know the slope, again you know f of what's the value. This height of this triangle is f of x1, and the base size of the base of this triangle is, and this is kind of x2, your value of x2, right? So x2 minus x1 minus x2 is then the base, and f of x1 is the height, and f prime of x1 is the slope. So you use the same formula to find out x1, and you keep on doing this until you have a value which is, you say I have, I'll just keep on doing this. That's like your prescription, until you hit some tolerance. What do I mean by this is that you'll see that the value, if the root exists, the value is going to converge. And the way it is going to converge is you say that at every after some n number of iterations, you do something like this. So the idea here is that xn plus 1 is then xn minus of f of xn by f prime of xn, where f prime means the derivative, right? So the idea here is then you keep on doing this unless you have xn plus 1 minus xn modulus of this by xn. So this entire thing modulus is less than or equals to, I mean, you keep on doing this unless it's greater. So it's greater than your tolerance. So that can be, say, for example, 10 to the power minus 6. So when the two roots, that would, what that this means is that it's come very close to the true value, which is shown in black. So you'll see that you start from a value which is very far away, and then you gradually move on to a value which is close to the black point. And when you have reached sufficient tolerance, according to whatever tolerance you want, you say that this is your answer. So this is roughly speaking how Newton-Raphson behaves and how you the algorithm of Newton-Raphson is. And now it's up to you to code it up and see it for yourself in the assignment. And perhaps I can just briefly also give you like pointers on how you would do this. So for that, let me go back to let's open a new file. Let me call it do just a hello world code just for to get started. Accept this. Okay, so this is just a simple hello world code, and then I'll include stdlib, and I'll also include the math library. And after that, let's have the function float let's say we have a function. So let's see. We can try the function which we have already tried in the example. Since there is some time, let's just briefly walk you through this as well. Let's go to, I think this was assignment 1. Yeah, so this is 2x cubed minus 3x minus 5. So 2 times x cubed minus 3 times x minus 5, right? And that's, we also have to know, like in Newton-Raphson, the other requirement is you have to also know the derivative of this. So I'll do a function prime, and so you 2x cubed will is going to give you 3 like 2. So let's see for let's see what your function is. It's 2x cubed minus 3x minus 5. Oops. 2x cubed minus 3x minus 5. So if you find derivative of it, it should be 6x squared minus 3, right? And that's what we are going to write, 6x squared minus 3. So now we'll start with this guess. Float x naught. Now, so we'll put in an initial guess. We'll take the guess. So this is x1, and we'll have a tolerance. So let's write it as float tol this. So we'll have a tolerance, and let's 1.0 e minus 0.4. That's kind of the tolerance that we want. And after that, you see this is pretty simple. I am just doing x naught equals to x1. So that's what I start with. And now I do x1 is equals to x naught minus function of x naught and function prime of x naught. So that's a new value. I come back, the new value becomes x1, and I keep on doing this. So I have a point statement. The root of this equation is this. Okay. So now I just launch this. So let's see. In Desmos, we have, I think, done this. Let's see. So this is has a root somewhere between 1 and 2. So let's guess this as 2, right? And then we will be trying to then see how Newton-Raphson behaves when I give a guess of 2. So let's go back to VS Code and give a guess value of 2. And you see, it goes on and tries to find convergence and then gives you the result, which is around 1.718854. So this is roughly speaking how you would have a Newton-Raphson method, and then depending on your guess value, or you will then going to get things which are close to the guess. So you see, I give a 1.5 and then refined, and then you get the guess, which is 1.7189. So depending on the guess value, you need a few number of iterations, and this will then converge to the closest root in a function. So this is basically the Newton-Raphson method, and I hope that this is kind of good enough for you to understand and follow how this is working. I gave you like a drawing which is roughly for just any generic function, and I hope that this is kind of interesting to you, and also you are able to follow up like how this method works out. So now if there are any questions on this, please feel free to ask, because this is the time. We are at the end of week 10, and we have discussed all the assignments. So please feel free to ask any questions if you are having any right now. Okay, since there are no questions right now, I would then end the session for this week. And I hope that you have learned about pointers, pointer arithmetic, different searching and sorting algorithms, and also about root finding. We have specifically worked with the Newton-Raphson method and the bisection method for root finding. We have worked with selection sort and bubble sort. We have used pointers and pointer arithmetic for referring to different elements in the array and moving through the elements. And this, I think, gives you a clear and solid ground in using C and also working with pointers. And I hope you are now confident enough to answer all the questions asked in this week. And on that note, I thank you all for listening to me. Thank you all for your time, and have a nice weekend then.